I just wanted to touch base about this week's HQ challenge. So a respiratory therapist is reviewing the chart of a 45-year-old male who presents in the ED 2 hours ago complaining of shortness of breath. You get a CBC, the hemoglobin level is 5, okay, they're anemic. And an ABG indicates his SATs are 98. So he's anemic, doesn't have a lot of hemoglobin, but this hemoglobin he does have is saturated at 98%. Which of the following is false regarding this patient's condition? So hypoxia is present because number one, when we figure out O2 content and we calculate that formula, that O2 content is going to be abnormally low. So this is a true statement. We're looking for a false statement. All right, so it's going to be abnormally low, which means there's not enough oxygen in the blood for the tissues to pull from. Therefore, the tissues are going to be hypoxic. That's a true statement. All right, so we're looking for, is the patient blue or are they not? Do they have cyanosis or are they acyanotic without cyanosis? So, test taking tip, if you have two responses that are polar opposites, cyanotic and acyanotic, the answer is probably one of those, okay? You just got to figure out which. So if we're having to do a little bit of guessing, you've drilled it down to at least B or C. But let's explain why it is what it is. All right, so this is a vial of blood containing 100 milliliters of blood. And this vial of blood is on this patient that hemoglobin is 5. Remember the definition of cyanosis is blue discoloration of the skin caused by greater than 5 grams percent of reduced hemoglobin. And that's the hemoglobin that doesn't have anything on it. Oxygen's not on it, carbon monoxide is not on it, nothing's on it, okay? Reduced hemoglobin. If you need a more thorough explanation of this, look at my YouTube video or go to my website and I explain reduced hemoglobin a lot more thoroughly. But basically, if you look at this 100 mLs of blood, they don't have much hemoglobin, so they don't have a lot of hemoglobin molecules here. So the red are the oxygenated hemoglobin molecules. The blue are the reduced hemoglobin. So if I could go in and pull out all those blue hemoglobin and weigh them, for the patient to be blue, they have to weigh greater than 5 grams, and there's not a lot there. So chances are it's not going to weigh more than 5 grams. Therefore, the patient is not going to be cyanotic. They will most likely be acyanotic. Anemic patients don't turn blue very easily. The more anemic they are, the more waxy, pasty, and pale they are, but they rarely turn blue. So hope this has helped. See you soon.